In this video, we are going to be discussing section 14.2, translations and reflections of trigonometric graphs. This begins on page 915 of your textbook. Alright, so we have done translations before, we have done reflections before, and it's just all about applying it to a different function. Alright, so here we still have our lovely sine and cosine functions. Just like before with a quadratic function, or with the absolute value function, or a cubic, or a quartic, or the square root, or the cube root, we have A's, we have B's, we have H's, we have K's, and they all have similar functions here, alright? So the A is still gonna, just like with a parabola, it determined you opening up or down. It's going to, signify that if it's negative or positive, it's going to tell you whether there's a reflection or not. That H is your horizontal shift. That K is your vertical shift. And B, just like in the past couple of sections, B still deals with your period. Alright, so for sine and cosine, we have this 2 pi over B. Alright, so that's important for us. For sine and cosine, period is 2 pi over B. For sine and cosine, period is 2 pi over B. And the amplitude is A. Alright, so we're going to start with the amplitude, and we're going to get a point up at the amplitude. We're going to have that 2 pi over B, and then we're going to apply our horizontal and vertical shifts. Alright, so we need to identify all those parts. That is step 1. So let's go ahead and say we identified all our parts. Step 2, draw the horizontal line at y equals k. Alright, so whatever this vertical shift, we need to draw a horizontal line. And this is going to be called the midline. Alright, so let's go ahead and say that k here for sine, let's go ahead and say that was 4. Alright, so I'm going to take my lovely, just regular sine, and I'm going to be, shifting it up 1, 2, 3, 4, and here's this kind of dotted line, and that is going to be my new midline for my sine function. Alright, so let's go ahead and say we drew that line. Find the 5 key points by translating the key points of your regular a sine of bx, forgetting that horizontal and vertical shift. Alright, and we're taking that a sine of b and we're shifting it up, down, left, right. Alright, and we're going to do the same thing if it's a cosine. Alright, so we have taken our graph and we have shifted it, and then we draw the graph through those 5 translated points. Alright, so just like with a quadratic function or any of the other functions that we graphed, the nonlinear functions, we want 5 points. Those 5 points are going to give us a good curve to draw through. Alright, so let's go ahead and look at example 1. Graph y equals 2 sine of 4x plus 3. Alright, so we need to identify our a, our b, our h, and our k. So a is 2, and our b is 4, our h. So one of the tricky things when we're looking at h versus k is there a set of parentheses in here. Alright, so is there parentheses in which there's something in with the x? Alright, there is not, so h is 0, so there's no horizontal shift, and k is a positive 3. Alright, so that brings us to the end of step 1 where, we did identify b, and b was that 4, so when I use b, I now can compute my period. Alright, so like I said, when the horizontal shift is 0, there's no shift, so that's one less transformation for us. Alright, so we want to draw a midline of the graph. Alright, and it is always helpful, I can draw a general, sine of x here, and my midline of my graph is going to go up 3 units. Okay, So then find the 5 key points. Those are my 3 steps here. So those key points, I am taking 0, 0, and then I am adding 3 to my y. Alright, and that's how I get my first point. And then the pi over 4 comes from when you take that period and you divide it in half, alright, to help find those critical points. So we are shifting that up again. These are my x-intercepts. So those are 3 of my points. And then I have a maximum. One of the maximums is going to occur halfway between my first 2 x-intercepts. And then I've got a minimum, and that's going to occur halfway between my second 2 x-intercepts. Alright, and then finally step 4, draw a graph through the key points. So there is my lovely graph. Alright, it has shifted up, and we can see what all of those numbers in our function have done. Alright, so the period is no longer 2 pi, it's pi over 2, because that b was a 4, and we can also see the 2 all the way at the front for the amplitude applied here, so the distance there is 2, the distance there is 2. Alright, so it all checks out. Alright, so example 2. Graph y equals 5 cosine of 2 x minus 3 pi. So yet again, we're going to want to identify our a, b, h, and k, and then we use our b to find our period. Alright, so that's step 1. My a is my 5, and my horizontal shift is a positive 3 pi. Please remember that the inside is opposite. It is x minus h on the inside there, so it's actually a positive 3 pi that replaced h. Alright, just like it's been for all the other functions. And then our b equals 2, so that makes our period pi here, and our vertical shift is going to be 0, since k equals 0. So, starting my graph here, I want to go ahead and draw my midline. Since k equals 0, my midline actually stays on my x-axis, which is really nice. And then we want to find those 5 key points. Alright, so a reminder, this is cosine, so it starts up, goes down, and then comes back up. So here I have 2 x-intercepts, and then I'm going to have 2 maxes and a min. Alright, and it would continue oscillating. Alright, so that is going to be 1 cycle, 1 period that I'll be looking at. So, these key points here, when y equals k, I have this pi over 4 plus that 3 pi for my horizontal shift. And in case we aren't remembering, I need to convert this into fourths, so that is 4 over 4 times 3 pi, or pi over 4 plus 12 pi over 4. So that's where the 13 pi over 4 comes from. Alright, and so then I do the same there for my next critical point, and then I compute a maximum. And another maximum, and then my minimum. Alright, and where all those points come from, you can look back in section 14.1 to figure that out. Alright, it's just all about chopping up these oscillating curves in ways that make sense, and finding these points and connecting the dots. So, here is what our lovely new graph looks like. Alright, its midline is still here on the x-axis, and then if I were to look at one period, I chop that there at pi. So I know that half of my period is here at pi over 2, and halfway in between, at that pi over 2, that's your minimum. At the beginning and end of your period, 0 and pi, that's where my maximums come in. and then my x-intercepts are halfway in between that pi over 2 and 0, and pi over 2 and pi. Alright, so example 3. Ferris wheel. Suppose you are riding a Ferris wheel that turns for 180 seconds. Alright, so that's 3 minutes. Your height h in feet above the ground at any time t in seconds can be modeled by this equation. Alright, lovely. We have an equation. All these words, blah, blah, blah. Alright, graph your height above the ground as a function of time. All that means is I have t. Alright, t on one side and h on the other. So if you're ever asked height as a function of t, h is going to be the one isolated, the variable isolated on the side. So graph it. Alright, we've just graphed, so this is a sine function, so I am building off of something that looks like this. Alright, and what are your maximum and minimum heights? So, setting up this problem, the amplitude is 85, the period I compute as 2 pi over pi over 20. So if you type that into a calculator, you're going to want to be careful. Or you could do the keep, switch what you're doing, and flip. Keep, switch, flip. Alright, pi's cancel out. 2 times 20, 40. Alright, and then the wheel turns. 180 divided by 40. So the reason they do that is you have 180 total seconds, and your period is 40 seconds. So we're trying to figure out, okay, how many periods are occurring, how many cycles are occurring, and that is 4.5. So you go around 4.5 times in 180 seconds. So the graph shows 4.5 cycles, and the 5 key points are listed. Alright, and so we look at these points. These are the 5 that we are looking at. And you find, this midline, you find those 3 points by looking back at your equation. You find the maximum and the minimum by looking back at the equation. You are looking for how to divide this up. Alright, so if we go back one more time, A here is 85, so that determines your amplitude. So here, this distance right here is 85. 85. And then there's also going to be 85 below that. Alright, so the total height here is 85 times 2, which is 170. All together. So if I go back to my problem here, I do need to keep in mind this vertical shift of 90 right here. So that vertical shift of 90 makes sense that this midline would be right here at k equals 90. So that makes these 3 points, this one, this one, this one, make sense as far as what would be our x-intercepts with that vertical shift. Now, when I said 170 over here, and you're seeing 175, and then if you were to calculate the minimum, and you're seeing 5, this might be confusing, and I think this word problem actually cut out a piece of information. As you can see, this wheel, alright, look at the wheel. If you had a proper Ferris wheel, it's not going to be resting on the ground. There is a little bit of support there. So I think that's where they have 5 feet, and they don't actually list that in the problem anywhere here. It doesn't say that it's 5 feet above the ground. So that is calculated into the maximum and the minimum heights here. Alright, so let's go ahead and finish out example 3. So your maximum minimum is that 175, and your minimum's 5 feet. Alright, so let's check out these guided practice. Go ahead, graph them, and pause the video, see if your solutions match. Alright, hopefully, you're starting at that midline, and then you are listing your period. So here my period is that 2 pi, chopping it in half, chopping it in fourths, alright, to find those critical points. Alright, so there is your solution. So here's guided practice number 2. And let's go ahead and move that down. Alright, pause it for a solution. Guided practice number 3. Alright, so the second concept here is that reflection piece. So we are all talking about whether A is positive or whether it is negative. Okay, so this reflection is going to be over the x-axis. So if I have my lovely sine parent function and it becomes the opposite of sine, I'm going to be flipping it over the x-axis and reflecting it. Alright, if I have my parent function for cosine, I'm going to be reflecting it over the x-axis. So what was up here now gets reflected, alright, and there is still that curve in there. Alright, so we still are going to be following, creating that midline, then chopping up your period and finding those critical points, those 5 points. Alright, so example 4. Graph y equals -2 sine of 2/3 x minus pi over 2. Alright, so identify all of your pieces here. You have your amplitude, which is 2. Your horizontal shift is pi over 2. Alright, so that means it is going to be pushing pi over 2 to the right. And then I identify my b as 2/3. And I want to be very careful here since I've got a fraction and fraction. And my period ends up being 3 pi, which is a little bit, since this is odd, it's going to be a little bit more difficult to, chop into those pieces. Alright, and then my vertical shift, luckily, is 0. So draw that midline at 0, k equals 0, which is still the x-axis. Alright, and then identify your points here. So, I have the computations listed there, my lovely points, my maxes, my mins, and then I need to reflect the graph because a is less than 0. So it's only really one more step than what we have been doing. Alright, so 5 pi over 4, comma 2, that point ends up with the y value of -2 instead. Alright, so this is what our final graph looks like, with all of the shifts and the adjusted amplitudes and everything, in addition to the x-axis reflection. So your x-intercepts, those points on that line, alright, on our midline, are going to stay the same. So when we do see that a is negative, we need to make sure to have an extra computation for our maxes and mins to get those in the right area. Alright, so just like that, I need to change my y value for my max as well. And that is my final graph. Alright, if you guys have any questions, you need to send me emails so that I can hopefully help fix you all and give you some better guiding notes for you. Alright, so good luck, and I'll see you soon.